4.3 Electrical Circuits Memo. Question 1. A circuit is set up as seen below. Okay, so we've got a 12 volt battery or cell, and then two resistors wired in series, so 100 ohm and a 200 ohm resistor. Well, it says find the current flowing through the circuit. So it's a series circuit, so we can think, well, we've got the total resistance would be 200 plus 100, which would be 300 ohms. So V equals IR, so V over R equals I. 12 divided by 300 is 0.04 amps. Find the potential difference across the 100 ohm resistor. Well, the current's going to be the same everywhere in the circuit. So the resistance times the current is going to give us the voltage. So 0.04 times 100 is 4 volts. Find the energy dissipated from the 200 ohm resistor over 2 minutes. So this is a formula meant to know E equals ITV. So we know the current is 0.04 amps. Times the time, so it's 2 minutes, but we need that in seconds. So 2 times 60 times 8, and we get 38.4 joules. Question number 2. So the circuit is set up as seen below. So now we've got a 10 volt battery. We've got a 200 ohm resistor and a 100 ohm resistor, and we've got these two diodes as well. And it's important to note the direction of the diodes, because remember, diodes only allow electrical current to flow in one direction. So the diodes in the circuit have a threshold voltage of 0.6 volts measured across them when the current flows through them. So if current's flowing through them, they will take from our circuit 0.6 volts. State the current through the 200 ohm resistor. Well, it is 0. Hopefully you got this, because the diode is in the wrong direction for current to flow through it. No current is going to go through there. What's the potential difference across the 100 ohm resistor? Well, if we have 0.6 volts across the diode, and we've got 10 volts in total going into our circuit, then across the 100 ohm resistor we're going to have 9.4 volts. Calculate the current through the 100 ohm resistor. So I is V over R. So 9.4 divided by 100 is 0.094 amps. Calculate the power dissipated by the 100 ohm resistor. Well, P equals I times V. So 0.094 times 9.4, I get 0.88 watts. Question 3, a wire is carrying a current of 3 amps and it goes into a junction connected to 2 other wires. If one of the other wires carries a current of 1 amp away from the junction, what's the current in the third wire? Well, it's going to be 2 amps. So we've got 3 amps going in, and we have to have 3 amps in total leaving or of current. So it's going to be 3 equals 1 plus 2. Number 4, the combined resistance of a pair of resistors is measured as 50 ohms. Given that one of them has a value of 200 ohms, what's the value of the second resistor? So 1 over R total is 1 over R1 plus 1 over R2. So 1 divided by 50 is equal to 1 over 200 plus 1 divided by R2. And we just need to rearrange this to find out R2. And if you do that, you get 67 ohms. Okay, number 5, we've got a potential divider circuit is set up as seen below. So 8 volts, 8 volt cell or 8 volt battery. We've got a 50 ohm resistor and a 150 ohm resistor set up in series. Calculate the potential difference across the 150 ohm resistor. Well, we can use the ratio of the resistors if we want, or we can use this equation that I've kind of pinched from the AS level. So V out is V in times R1 over R1 plus R2. So in this case, our R1 will be 150 ohms. So 8 times 150 divided by 50 plus 150, we are going to get 6 volts. And then 6, it says find the total resistance of the resistor combination below. So here we've got resistors in series and parallel. It's best to deal with the ones in parallel first. Okay, so we have just the combination of the resistors in parallel. Excuse me. So we've got 1 over R total is 1 over R1 plus 1 over R2. So 1 over 200 plus 1 over 400, I get 0.0097. Find the reciprocal of that, and I get 133 ohms. So that's just for the parallel combination. Then I just need to add that to the 50 ohms, and I get a total of 183 ohms.